So let's continue with our subroutines. On the left hand side we have the original program which we seen in the last video, which reads the characters from the keyboard and prints the characters to the screen. Now we're going to take the first part of this, which is the read loop. So this is the reading characters from the keyboard, and we're going to generate its own little subroutine. Now, the first thing we're going to think about is what do we want to call the subroutine, so that each time we use, for example, the jump to subroutine, that is JSR, it's going to have a name. So I decided to call this get underscore character because we're getting a character from the keyboard. So the routine here is called get underscore character, and you can see all I've done is I've taken in the program here for the get character. So this line here is the same as this line, and each of the lines are the same until you get down to the jump if equals. Now at this point here, the jump if equals tells us that we've actually counted through, in this instance, all 12 characters. So we will have read in all 12 characters. Now if we have read in all 12 characters, what we want to do is return the control from the subroutine back to the main program which called it. So we jump if equals to the routine that's called ret. Okay, so we come down to ret here, and it's just got the return command. So we just return back to the original subroutine. Now, if we haven't read in all 12 characters, then it'll jump back to the beginning of our get character subroutine, and it will continue through that process. So this is our subroutine, but there's a couple of things that we have to be careful and we have to make sure we add into this subroutine. First thing is we know that the subroutine has to go into the ROM, so we're going to have to tell it where to find the subroutine. Now I've decided to place it in this address here, which is 0x150. Now it's very much kind of random. I've just picked an address somewhere within the ROM, but not at the beginning of the ROM, because at the beginning of the ROM I'm going to use that for little bits of our operating system. So I've used this start address here, so it means that it's going to store the value, this program within at that location, at the beginning at that location. Now the other thing to note here is we're going to have to tell it what the keyboard underscore input is. Okay, so the keyboard input is defined as this memory address here, 0x FFF0. Okay, so this is the entire program that we need to assemble. So what we'll do is we'll go ahead and we will assemble this. Now once it's been assembled, we'll have to go and save it into the ROM. So let's go do that now. So we have our get character subroutine sitting in the directory that we need it to be in order to run through the assembler. So we have the assembler here and we can run through this. So that's generated the assembly language. Now you can see here at the very bottom we have the actual output which we require for the subroutine. So what we will have to do is we will have to take these values and we will have to enter them into the ROM at that location 150. So I will go ahead and do that now. So if you head into the ROM, you can see I've actually already gone ahead and updated these values. So you can see at hex address 0150, I've put in the get character subroutine. Now again, you can get the subroutine if you head into your Python folder and get into machine code and you've got the machine code _H, and you'll be able to see the values within that output. So these are the values that we want to enter into our subroutine in the ROM starting at address 150. So that's them in here. Now those values will stay in here. Even if you were to close the program down and open it back up again, it will still be there. So let's go ahead and we will actually test out this little subroutine. On the left hand side we have our get character subroutine. Now this is the routine which we have already entered into the ROM, and we want to test this subroutine. So I test it with this little program here called test_get character subroutine. So it starts at address 8000, and again we have to set up the values in a register. One of the registers contains the number of characters, which is 12. The other register, which is the index register, contains the start address of our first character. Now once these have been set up, we can then jump to the subroutine. So we jump to subroutine get character. But of course, this jump to subroutine get character is just another address, and we have to actually tell it which address. So we tell it the address down here. The EQU3 is get_character, which is this address. So we jump to this address. Now when we jump to this address, it's in effect equivalent to us jumping to the first line of this subroutine here. So we jump from here into here and we run through the subroutine. Now when the subroutine has finished, we get the RET, which is the return command. Now when it returns back to this line here, which will be the end line. So it returns to the address one after the last instruction, which is this instruction here. And that's the end of the program. So let's go ahead and we will assemble this, and then we'll test it and see whether it actually works. So we have our get character subroutine test in here, and we can run through the assembler, and that's it, generated the assembly language code. So now we can go ahead and we can load that into our CPU. So first of all, we will reset everything, and we'll drop in here to the CPU, and we'll load in the program. Now that's us ready to run the program. Now we still have to put in our hello world. Now whenever we run this, it should run the same way as the previous code ran, but the difference now is that we're going to go to the subroutine in order to run it, as opposed to running it from the RAM. So I'll just run through this now. And you can see here it's loading in these values, and it's working through the same process. So when it's finished, in fact we can get in now and we can see it actually happening. So at this point here, it will be loading up the values into the RAM. So you can see here, these are the values for H, E, L, L, O space and the world. Okay, so it has taken all the values and loaded them into the RAM, and we should be now at the very end. So we've got the end routine end section here. So it does work, and it does go in and it works via the the subroutine. Now what you can do, and I won't do it here because it's going to make the video far too long, we can go in here again and you could run through the whole process again. And we can reset it and load up the program again. And I do suggest you do this at least once to understand the whole process. Now what you can do is you can run through it one step at a time. So we can go through again, setting up the stack pointer and then jumping to the first address of the program and then working through the first instruction, which puts the value 12 into register R1, and then we can see it. If you follow each of the individual lines of code, you'll be able to see it jumping over to the actual ROM and working through the code within the ROM as opposed to working through the code in the RAM. Now, as I said, I'm not going to go through every line in detail here, but you can work through with every clock pulse and you can chase up every single part of every instruction, and you can see exactly how every 1 and 0 passes through the CPU in order for us to jump to this subroutine and run through the program. But you've done this several times before and in the first course, so you should be able to go through and have a look through this for yourself. And you can actually see here at the bottom, you can see the stack pointer here is actually dropped by a value of 1 because we're using the stack in order to save the return address. So that's well worth going through at least once. Now let's finish this off and we will have a look at the write loop, and then we'll put them together in one program. On the left we have our original program which reads from the keyboard and prints to the screen. We've already worked through the reading from the keyboard. We're now going to work through the writing to the screen subroutine. So we're wanting to take this section here and generate the subroutine. Now I've generated the subroutine here. Now again, I have to pick a name for it, so I decided to call it print_char. So it means that whenever we use this subroutine, we're going to use the JSR space print_character. So it will go to the ROM and find this subroutine in the ROM. Now the first few lines are going to really be the same, so we're going to have our load IND with R0, screen R0, store R0, screen output, and all the way down here until we get again to the jump if equals. But this again, when we get to jump if equals, then we go to the return, and here's the return here, which gives us the actual return command. So it will return control back to the previous subroutine. Now, if the jump if equal isn't true, then it jumps back to the beginning of the print character subroutine, and it will continue all the way through, counting down until eventually it's done all of the characters and it's printed all of the characters. Now, one other thing to note here as well, or two things to note, we're going to have the screen output, so it needs an address for the screen output. So the screen output is given here at this EQU3, so it gives us the screen output as 0x FFF3. Now, one other thing is we need to know the origin for this program. So the origin for this program is going to be 0x160. So it's the line down below the read function, which our subroutine which we just generated a moment ago. So this is our subroutine. We're going to have to then run through the assembly language and then take a copy of the output from the assembled code and then put it into the ROM at the correct position. So I'll just go ahead and do this now, and you can also go ahead and do it. So I have assembled that piece of code, and I have the machine code here in hex. So I've taken this machine code in hex and I've entered it into this address position here. So it starts at this position here, and I've entered the values in. So this is going to be our print character subroutine within the ROM. So what we want to do is write a program which again will test it. So let's do that now. So again, on the left hand side we have our print character subroutine which is in the ROM, and we have the little test program which will test to see if it works. So we start off at address 8000, we set up the number of characters in register R1, we set up the address at which the characters are stored in the index register. At this point now we're going to jump to subroutine print character. So at this point it jumps over to the print character, it goes through this subroutine here. Now when it's finished the subroutine, it will return control back to the calling function, which is the original assembly language code. So it will return back here, and when it returns back it will go to the next address after the jump to subroutine. So it will go to this address here, which is the end. And the only differences here now are we're using the print character, and also the address for the print character is actually 0x0160. So let's assemble this and we'll run it and we will see it working. I have the test print character subroutine sitting in the correct folder here, and whenever I run up the assembler I can type the run, and that's it, assembled the code. We can then take this code and we can load it into our CPU and the RAM. Now, in order for us to actually see this working, it assumes that we already have the values within memory. Now, right now, we don't have the values within memory because we haven't put any values into memory. We haven't read it out of the keyboard and put it into memory. We're just sitting with empty memory locations. So what we would have to do is, in order to see this working, we would have to put the values for our hello world into the required memory locations. So I will go ahead and do that now, and I'll show you where those values go. So I have gone ahead and I've put in the ASCII values for hello world in the correct memory locations. So that's it starting here. That's 0068, so that's HELLO space and then world, and at the end the exclamation mark. So now we're in a position to actually run the simulation. So I will adjust the speed here so that it slows it up a little bit, and it should print out the values hello world to the display, but of course it's printing it out using the subroutine. So let's run this now. And you can see here it's printing out hello world. So it does work, and both the subroutines do work. So finally what we want to do is put both subroutines into one program, and that'll do us for this video, because this video has gone on quite a long while now. So finally here is our code which will use the subroutines for both the get character and the print character. So what we've done is we've taken this code here and we've replaced this with a subroutine and this with a subroutine, and you can see the subroutines here. Jump to subroutine get character and jump to subroutine print character. And you can see how much it has shortened our code. And of course that code for the getting the character and printing the character is within the ROM, and it's saved within the ROM, and we can go and use it whenever we need to. We just need to know where the get character and print character values are held within that ROM. So that's all for this video. It's been very long, it's been quite complicated. I'll leave all of the code that you require in the resources section for you to go ahead and simulate all of this. And I suggest that you go in through the simulation and you can go through one clock pulse at a time, and you can check and see exactly what's happening. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.